Alright, so finally we've got to use the definition of continuity to find the value of a so that g of x will be continuous for all real numbers. So looking at this function, I see that it's a piecewise function. That is the first thing I notice. In order for something to be continuous by the definition, I want the limit from the right hand side to equal the limit as x approaches 1 from the left hand side to equal f of 1. Alright, so guess what? Just like before, this is going to be from my right hand side, and this is going to be from my left hand side. So that's nice, that's neat. So I want x squared plus 7 to be equal to x plus a, when x is equal to 1. So go ahead, plug in 1. So I'd get 1 squared plus 7, because that is my limit as x approaches 1 from the right. Should be equal to 1 plus a, that is an a, not a 9. And then all we have to do is simplify this. So 1 squared should be 1, plus 7 should be 8, should be equal to 1 plus a. So solving for a, just like in Algebra 1, a should be equal to 7. Alright, and then at this, so what we want is the limit as x approaches 1 from the right to equal the limit as x approaches 1 from the left, which is equal to f of 1. We want all of that to equal 7. Surprise! Alright, same type of deal on example 6. So, again, now I'm looking at 1 again, which is kind of nice. We do see that we have a discontinuity at 1, so I kind of want to fill that in. So, the really nice thing here is that besides at 1, this particular bit of function should be approaching the same thing from the left and the right, which means really all I have to check is the limit as x approaches 1 of h of x has to be equal to h of x. So I've just got to figure out what the heck this would be near 1, so let's go and do this. So first thing I'm going to do is I'm going to try to plug in 1. I get 1 to the 4th, which is just 1 minus 1, all over 1 minus 1 up top. Well, crap, that doesn't work, so I need to do something else. And so the next thing I'm going to try to do is I'm going to try to factor this whole mess. So let's factor the top of that first function up top. So I should get x squared minus 1, because that's the difference of squares, times x squared plus 1. Alright, and then I see that this top bit is still a difference of squares. Alright, so that can get factored again, so I get x plus 1, x minus 1, all over x minus 1. And I still have that x squared plus 1 up top, I'm in the process of writing it. Alright, so then I see that, hey, these x minus 1s cancel out, leaving me with just x plus 1 over 1, and I've still got that x squared plus 1 sitting there. I always forget my limits. Don't be like Miss Schuessler. Be better than her. Alright. So now what I'm going to do is, now I've got what I can to cancel, I'm going to go ahead and I'm going to plug in 1. So plugging in 1. I don't need my limit sign anymore, so 1 plus 1 times the quantity of 1 squared plus 1 should give me 2 times 2, which should equal 4. So all in all, I want k to equal 4. Most time I need to check my limits from the left and from the right. Whoops, I pointed at those backwards. Try that again, from the right and from the left. But since this particular function has just a discontinuity possibly at 1, I just need to know what it approaches from the left and the right, which just happens to be the limit in this particular case. So I factored and I canceled what I could to figure out what k was, so k should equal 4.